Hello students, welcome to the online lecture series for the subject complex variable and partial differential equations. Myself Ankit Acharya, and this is our third lecture for the chapter first order partial differential equation. In this lecture, we will discuss about formation of PDE by elimination of arbitrary function. But now this time our function is a function of two variables. So you can see on the screen, consider the equation. We are considering the equation f of u b equal to 0, where u and b both are function of x, y, z. Right? Now for this type of function, and if we want to find first order partial differential equation, if we want to make a first order partial differential equation from this equation, then you have to remember this important formula. The formula is, you can see on the screen, the partial differential equation associated with this type of equation f of ub equal to 0 is p into del ub by del yz plus q into del ub by del zx plus that is equal to del ub by del xy, where now all these derivatives are nothing but Jacobian determinant. So you can see del u b by del yz, that is equal to 2 cross 2 determinant del u by del y. First row is del u by del y, del u by del z. Second row is del v by del y, del v by del z. Similarly, you can see del u b by del zx, that is equal to del u by del z, del u by del x. First row is del u by del z, del u by del x. Second row is del v by del z and del v by del x. Okay, and similarly del u b by del xy. Similarly, you can define del u by del x. First row is del u by del x and del u by del y, and second row is del v by del x and del v by del y. So you have to remember this important formula, and these three derivatives are nothing but Jacobian determinant. So let's see how we can solve this type of example, how we can find first order partial differential equation from the function f of u b equal to 0. So let's see first simple example. So this is our first example. Find partial differential equation corresponding to f of x minus z, y minus z, that is equal to 0, where f is arbitrary function. Okay, so you can understand first of all what is u. U is equal to x minus z. Okay, and what is v? V is equal to y minus z. Easy to understand. Okay, now first we find del u b. First we find del u b by del yz. Okay, the first Jacobian determinant, you can see from this equation del u b, this is our first determinant, del u b by del yz. Okay, so first I find, now you can see del u by del y, del u by del z, del v by del y and del v by del z. Okay, so what is del u by del y? I am just writing direct value. What is del u by del y? Del u by del y, that is 0, because u is a function of x and z. What is del u by del z? Del u by del z, that is minus 1. What is del v by del y? Del v by del y, that is 1. And what is del v by del z? Del v by del z, that is minus 1. Okay, so this determinant, that is equal to cross multiplication, 0 into minus 1, that is 0 minus 1 into minus 1. So final answer is 1. Okay, similarly now we find del u b by del zx. Okay, now del u b by del zx, when we find, so first row is del u by del z and del u by del x. So what is del u by del z? Del u by del z, that is minus 1. Del u by del x, that is 1. Okay, what is del v by del z? Del v by del z, you can understand from v is equal to y minus z. So del v by del z, that is equal to minus 1, and del v by del x, that is 0. Easy to understand. Okay, so minus 1 into 0, that is 0, minus 1 into minus 1, so that is 1. Clear? Now let's we find del uv by del xy. Okay, the third Jacobian determinant, that is equal to del u by del x. The first is del u by del x, so del u by del x is what? 1. So 1. Then del u by del y, that is 0. And del v by del x, that is also 0. And del v by del y, that is 1. Okay, so del u by del x, that is 1. This is del u by del x, del u by del y, that is 0. And del v by del x, that is 0, and del v by del y, that is 1. So this is also 1. So now you can understand, see, we find all this first order, all these Jacobian determinant. We find all these three Jacobian determinant, and now put all these values, because of all the values of all Jacobian determinant, that is 1. So now our final answer is what? P plus P into 1 plus Q into 1, that is equal to 1. Okay, so from this equation you can understand. So the final answer is P into 1 plus Q into 1, that is equal to 1. So P plus Q, that is equal to 1. Easy to understand. So this is our final answer. Okay. Now let's take one more example. Interesting example. Find partial differential equation corresponding to f of x square plus y square plus z square and z square minus 2xy, that is equal to 0. So first we are taking u. What is our u? I am just writing here. U is nothing but x square plus y square plus z square. And what is v? V is equal to z square minus 2xy. Okay. Now we find, first we find del uv by del yz. Right? Now what is del uv by del yz? First is del u by del y. Don't forget, this is del u by del y. This is del u by, just I am writing the formula del u by del y, then del u by del z. Okay. Then del v by del y and del v by del z. Here, so we find this determinant. Okay. Now, what is del u by del y? Del u by del y, that is 2y. What is del u by del z? That is 2z. What is del v by del y? Del v by del y, that is, you can see from this equation, del v by del y, that is minus 2x. Okay. And del v by del z, is what? 2z. Okay. Easy to understand. So again I repeat, what is del u by del y? Del u by del y is 2y, del u by del z, that is 2z. Okay, del v by del y. Del v by del y, that is minus 2x, and del v by del z, that is 2z. So this equal to 4yz plus 4xz. Okay. Now next is we find del uv by del zx. Okay, del uv by del zx. So I am just writing direct value. First is del u by del z. So del u by del z, that is 2z. Then del u by del x. What is del u by del x? That is 2x. So this is 2x. Then del v by del z. That is 2z. And del v by del x. That is minus 2y. Okay. So the value of this Jacobian determinant, that is minus 4yz minus 4xz. Okay. Now del uv, the last Jacobian determinant I find, del uv by del xy. Okay. So this equal to, first is del u by del x. So del u by del x is what? 2x. Then del u by del y, that is 2y. Okay. Then del v by del x. What is del v by del x? Del v by del x, that is minus 2y. Okay. So this is minus 2y and del v by del y. So what is del v by del y? That is minus 2x, right? So this is del u by del x. Del u by del x is 2x. Del u by del y, that is 2y. Okay, and del v by del x, that is minus 2y, and del v by del y, that is minus 2x. Clear? So this is minus 4x square minus 4x square plus 4y square. Easy to understand? Okay. Now I'm putting all this value in equation number 1. In this equation, see, this is our equation. P into del u v by del y z plus q into del u v by del z x, that is equal to del u v by del x y. So I'm writing all this value in that equation. So P into 4yz plus 4xz. First I am writing P into 4yz plus 4xz. Is this correct? Let me check. 4xz, correct. Plus q into minus 4yz minus 4xz. Okay. Plus q into minus 4yz minus 4, what is it? Minus 4xz. Okay. So minus 4xz, that is equal to what? Next value minus 4x square plus 4y square. So that is equal to minus 4x square plus 4y square. So 4 will be common and cancel out. So the final answer is P into yz plus xz plus q into minus yz minus xz, that is equal to y square minus x square. Okay, easy to understand. So this is our final answer also. You can simplify it. See, the z is common from these two terms, yz plus xz. If you want to take, and from these two terms you can take again z is a common, right? So that's okay, but this is our final answer. So let's take one more example. Find PDE corresponding for this equation f of x plus y plus z, x square plus y square plus z square, that is equal to 0. So u is equal to, here u is equal to x plus y plus z, and what is v? V is nothing but x square plus y square plus z square. Okay. So the first Jacobian determinant that we know, del u v by del y z, that is equal to del u by del y, that is 1. Okay. Del u by del z, that is also 1. Then del v by del y, that is 2y, and del v by del z, that is 2z. So that is equal to 2z minus 2y. So 2z minus 2y. Okay. Similarly, you can find del u v by del zx, right? Del u v by del zx. Okay. So now, if you understand the first column for the second determinant, that is nothing but the second column of the first determinant. So directly you can write 1 2z here. Okay. Right? If you remember properly, then this is nothing but del u by del x, and del u by del x, that is 1, and this last entry, that is nothing but del v by del x. Del v by del x is what? 2x. So that is equal to 2x minus 2z. Similarly, you can find del u v by del u v by del xy. Okay, so that is equal to the first column, that is 1 2x, and the second column, that is nothing but del v by del x, sorry, del u by del y, and del v by del y. What is del u by del y? That is 1. Okay, and what is del v by del y? Del v by del y, that is del v by del y, that is 2y. Okay, so this is equal to 2y minus 2x, right? So the final answer is P into 2z 2z minus 2y plus q into 2x minus 2z that is equal to 2y minus 2x. Okay, here and 2 will be common, so final answer is p into z minus y plus q into x minus z. Okay, p into z minus y plus q into 2 will be common, so plus q into x minus z plus q into x minus z, and that is equal to what is y minus x. Okay, so this is y minus x, right? So this is our final answer. So today we will discuss about how we can find Archer differential equation for from the elimination of arbitrary function, where function is a two variable. Function is a form of two variable u and v, where u and v both are function of x, y, z. So in that case you have to apply this method, right? So this is our third lecture for the subject complex variable and partial differential equation. In today's lecture we will discuss about the topic formation of PDE by elimination of arbitrary function, right? So thank you.